Three printing presses, R, S, and T, working together at their respective constant rates, can do a certain printing job in 4 hours. Can we get an equation from that first sentence? Well, one way to pull out an equation would be to turn to our trusty add up the rates to get the combined rate formula for combined work. So let's do that. What is the combined rate for all three of these machines working together? Well, we're told that they do one job in 4 hours, and a rate, well, that's just some amount of work per some amount of time. So their combined rate is just going to be one job per 4 hours, or a fourth of a job per hour. What about their individual rates? Well, we don't get any numbers, but we can just set up an equation with variables. We can say R's rate. We can just say R does one job in R hours. So R's rate is just that, one job per R hours. And S's rate will just be one job per S hours, and T's rate will just be one job per T hours. So we've got one equation, three variables. Let's see what else we can get. Next sentence. S and T working together at their respective rates can do the same job in 5 hours. So S and T, just those two machines working together, can do the job in 5 hours. So what's their rate? What's the S and T together rate? Well, they do one job in 5 hours. So their rate is a fifth of a job per hour. And S's rate is still the same. S's rate is still one job per S hours. And T's rate is still one job per T hours. So now we've got two equations, although there are still three variables in the mix, so we won't be able to solve for every single variable. So what is the variable that we want? Well, the question asks us, how many hours would it take R, working alone at its constant rate, to do the same job? So we need R's time to do this job, and that's actually exactly what the variable represents, right? This whole term represents R's rate, one job per R hours. And so the number on that, whatever we get for R, will be the number of hours it would take R to do one single job. So how do we isolate that R? Well, I guess one reason I wrote out the equations like this, with all the pieces lined up, is just to make it a little easier to see if there's an opportunity to use combination to cancel out some variables. And here we're in really good shape to use combination. If we just subtract this whole second equation from the first, well, then the S terms are going to cancel out, and the T terms are going to cancel out, and we're just going to be left with R. So let's definitely do that. So subtracting the whole second equation from the first, we get 1 over R minus, and there's nothing here, so we're just left with 1 over R. 1 over S minus 1 over S is nothing. That's just gone. Likewise, these 1 over T's cancel out. And on the right of the equation, we are left with 1/4 minus 1/5. Now we're in really good shape because we've got one equation, one variable. So let's keep going. Subtracting fractions over here, I need a common denominator. So what would a good common denominator be? Well, if I multiply this first fraction by 5 over 5, and if I multiply the second fraction by 4 over 4, then I'm going to end up with 20s on the bottom for each. So then this side becomes 5 over 20 minus 4 over 20, which is just 1 over 20, which means my whole equation now is just 1 over R. So from this side equals, and then this side 1 over 20. So 1 over R equals 1 over 20. Well, I can just flip both of these to get R equals 20. And we said early on that R, that is going to be directly our answer. That will be directly the time it would take R to do that one single job. So 20 is our answer, which shows up in answer choice E.